Welcome back. So in previous lecture we discussed about different type of plate boundaries and tried my best to explain you. Now further, this was the last slide where we stopped. Now the arrows which have been shown here are the plate motion. Now this has helped us in understanding that how different plates are moving and with different velocities. This is very important finding, and the measurements which have been done by GPS, and most of the countries now are having a very good network. Even in India, we are deploying as many as GPS we can under the projects we got sponsored from Ministry of Earth Science. Not only the IIT Kanpur is doing that, but there are many other institutions, mainly the National Seismological Center, Ministry of Earth Science is at New Delhi, is handling most of the deployment of permanent GPS stations in India, and we are also doing some part in Himalaya. Now the aim is to very precisely measure that what is the convergence rate, or maybe the plate motion of the Indian plate. Now if you see here, we have like some places we are having very long arrows indicating that the motion is very fast. That means the convergence between the two plate boundaries is very large, and this also has an implication towards the hazard in terms of the earthquakes. Now if you look at this map which shows the relationship of the plate boundaries and the alignment or the orientation, or you can say the locations of the earthquakes. Most of the earthquakes are along the plate boundaries. So this also helps us in understanding that these plate boundaries are dangerous in terms of the earthquake and the hazard associated with it. And not only that, we also are able to learn and understand that the earthquakes which are aligned along the plate boundaries are not occurring at the same depth. We are having the deeper earthquakes which have been marked by red dots. Then we are having the intermediate earthquakes and the shallow earthquakes. So shallow earthquakes are mostly most dangerous one, okay, because as I discussed in one of my lecture where I was talking about the 2015 Gorkha earthquake, there we emphasized upon that what was the focus, that is the depth of the earthquake. It was hardly 15 to 20 kilometers. Now if you come down to India here, we have mostly the collision zone, which initially I explained that the plate, oceanic plate ahead of this continental plate subducted below. So we are having right now the two continents have collided, but still we have the older plate which subducted initially. Hence we are having the collision plate boundary here, but this portion which we are having Sumatra, Andaman and Arakan subduction zone, we have the subduction zone, like one plate is subducting beneath the another one, and mostly what you see here is that you are having the shallow earthquakes. So this is more very much like in terms of the hazard posed by such earthquakes is very high, and the risk is also very high to the people who are staying in this region. Now one more important thing which you should remember is that, and I explained in one of the previous slides in previous lecture, that wherever we will have the one plate subducting below another one, we will have the signatures of volcanic eruptions. So this it shows the that the volcanoes are also are in a typical environment, or the relationship between the two plates, you will find that where one plate is subducting below the another one, you will have the volcanic eruptions. Otherwise, you will not see the volcanic eruptions on in all plate configurations. It is difficult because you need to have the source which will melt in the deeper part of the Earth's interior and result into the volcanic eruptions. So again, if you look at this is in subduction zone, so we don't have we have volcanoes here, but we don't have the volcanoes here in this area. Now, plate boundaries, as I was discussing, we have mainly you can say we can classify in three major categories. One is convergent, transform, and divergent plate boundaries. So, most movement occur along narrow zone between plates where the results of plate tectonic forces are most evident. There are three types of plate boundaries. One is your divergent plate boundary, which you can see here, this one. So, you have a divergent plate boundary where new crust is generated as plates pull away from each other. So, we also term this as a constructive plate boundary because there is no destruction which is taking place, and always new plate is been added up. Now, how they came to know that there is an addition of the plate? As one moves away from the spreading centers, what they found was that close to the spreading center, I will just put a line here. So, if you move away from the away from the center, then the rocks or the material, the molten mass or the magma which came up, what we found that we have, if you move away, we have older rocks. If you come closer, then you are having younger rocks. Okay. So, this was the finding which helped us in understanding that every time there is an addition of crust along these spreading centers. Then we have another one is convergent plate boundary, where crust is destroyed as one plate subduct under the another one, and these are the convergent plate boundaries where one plate, the oceanic plate, is subducting below the continental plate, or you are having an oceanic plate subducting below an oceanic plate. Now, the older oceanic plates will be relatively heavier than the younger one. So, this will subduct below the younger oceanic plates. And if you see, the sketch also tries to explain that the subducting plate which has been moving down or subducting down, when it reaches the asthenosphere, there is a melting which starts, and that results into the formation of the volcanic arc or the volcanoes on continental plate or in the oceanic plate, and this we termed as an island arc. And the area close to this subduction are termed as trenches. These are termed as trench, and trench will be the contact where will be the most deepest portion between these two plates and in the area where you are having the plate boundary. So, if I put in sketch here, then this is the overriding plate and this is the subducting plate, and suppose you are putting an ocean here. So, this will be the deepest part. This is termed as trench. So, you can recall if you are asked that what do you mean by trench here in relation with the plate boundaries. Okay. Then finally, we have the third one is the transform boundaries, where crust is neither produced nor destroyed as the plate slides horizontally past each other. So, this transform plate boundaries are been shown here actually. Okay, I'll just remove this part so that you can clearly look at. These are the transform plate boundaries, and they are associated with the spreading centers. Okay, see these lines here are the transform plate boundaries. So one is your constructive plate boundaries, another is your destructive plate boundaries, and further last one is your transform plate boundary. Now another example is, which I would like to add here, is of a triple junction, where three plates are moving away from one another. So we have three plates here which are and the area is termed as triple junction. So we have the East African Rift Valley spreading away, this one here. We have another one along the Red Sea. So you have African plate and Arabian plate here, and then we have the area along the Gulf of Aden, which is also moving away. See, the yellow arrows are showing the drifting of the different plates with respect to one another. So the East African Rift Valley spreads the continent apart at the rate of around 100 times slower than typical ocean rift zones. So this process along the African Rift Valley is very slow, but recently this was evident that some areas in this region has splitted apart. If I'll see if I have a movie, then we can show, or maybe in the next lecture we can show that movie where the people have been watching that how things have moved. But of course this phenomena is very slow, and maybe it will take a long time to break this land into two parts, and you will have a new ocean along this boundary. So this rift forms one arm of a triple junction from which the Red Sea and the Gulf of Aden forms somewhat more rapidly spreading rift. So these two are comparatively moving faster than this one. Now coming to this example is very good here, which has been shown as the Dead Sea Fault. Okay. So this I have already explained, that if you are having the oceanic plate subducting below the continental plate, then you will have one hazard which is related will be the volcanic eruptions. Another one is that if this moves and we have an water on top of it, so along with the earthquakes, which will be and very like mega earthquakes, we will also have the tsunami, because there will be a disturbance of the water column which is sitting on the top of this. So we have, like in such situations, or the plate boundaries where we talk about the subduction zones, we have threefold hazard which is associated with such tectonic framework. So on the surface also, when you are having the oceanic plate subducting below the continental plate, you can see beautiful volcanic cones or the eruptions which are been seen along the subduction zone. Now coming to this part here, this is one of the best example which one can see of the divergent plate boundary which has been experienced or seen on the surface. Okay, this is an example on the Iceland. So one where you are having the plate subducting below, you will have the volcanoes which has been shown here, and you have an island arc here, but at the places where you are having the magma chamber available below it, and then you are having again both the plates are moving away, then you will see and spreading out or diverging boundary of along the plate. So magmatic activity related to plate tectonics you can have in two different ways. So one is your formation of the island arc, another you are having the divergent plate boundaries. So this is an example from an Iceland. So if you take from here all these figures, what we see is that from where we are getting the magma source. One is the one plate subducting below the another one. This is an example of Nazca plate, and along the Peru-Chile trench, we are having the South American plate, which shows the evidence of volcanoes here. Then we have another is Tibetan plate, and we are having the Himalayas, but as I told that now we do not have any evidence of the volcanic eruption here, because two continental plates have collided. So, we are having the continental convergence, but previously we experienced, and we have the evidence that there were the volcanic eruptions in the past when we had an oceanic plate which subducted below and reached the asthenosphere. Then we have transform plate boundaries, and we also see at some places the example of transform plate boundaries. For example, in US, the American and Pacific plate boundaries, they are also showing the transform movement, and this is one of the example of the mid-Atlantic ridge, which has been shown here, which comes right into the surface in the Iceland, which shows that two plates are moving away from one another. So, convergence of oceanic plate and the continental plate, if you look at, so we have, for example, the Nazca plate. We have on the right hand side we are having the South American plate. I was showing the example in the previous slide. So, the oceanic plate, which is heavier, will subduct below the lighter one, that is your continental plate. These are few examples where you will be able to see the volcanic arcs, mainly in Alpine, Andes, West Coast, Cascadia, and Pacific North of United States. Now, let us see, I have some field photographs of this. So, on Google Earth, if you look at the trenches, looks like something like very sharp boundary between the two plates, and this is what the darker part which you see here is the deepest portion. So, if you take the cross section here, how it looks like is that this is going down, and then you are having the continent. So, this is your continental crust, and this one is your oceanic crust, and this portion is your trench. So, we had an opportunity to look at this the volcanoes here. Of course, they are active, but at that point of time when we visited the Chile, at that time it was not active. So, this is the trench portion here, and at the backdrop here what you see is the topography is the mountains, and within that we see a few volcanoes, active volcanoes. So, this is an example of this, and field photograph you look at. So, these are few examples of on Google Earth we have clipped up. So, this is one of the volcano which has been compared with the Mount Fuji. The name of the volcano is Osorno. This is in South American plate, and this is in the Japanese islands, okay, Mount Fuji. So, this is compared based on their appearance, they looks very similar. This is another example of the volcano in Chile. Now, there is another example of from Hawaii. Okay. So, what is the most important aspect which we should understand out from this, that over the time when this one plate is subducting below the another one, this is one example where we will have volcanoes, but in other cases if we have an hotspot which is supplying the magma to the surface, it will also result into the formation of the volcanic chain. So, if the plate is moving on the top of that, then we will keep on having the volcanic eruption. Now, this example from Hawaii also helped us in understanding and realizing or accepting the the hypothesis which was been given as in continental drift, that the plate moves from, or it moved from its original locations. So this is the island chain of in Hawaii, which we see almost like it takes turn over here, and this is the location where you are having the most active volcanoes in this region. There was 2017, if I am not wrong, there was the active eruption which was been reported from this island. Now, hotspot and absolute motion, this was again, it came in that during the 19th century, American geologist James Dana observed that the age of extinct volcanoes in Hawaiian island chain increases as one gets farther away from the active volcanoes on the big island. So this is the big island which they have marked. So if they move away, then they found that the ages are increasing. Okay. Earthquakes occur only near the active volcano. So this is connected with the magma which has been pushed to the surface, and because of that the fracturing and cracking and moving of the magma, or the movement of the magma, is causing the earthquakes. So in 1960, okay, Wilson proposed that long-lived hotspot lies anchored deep in the mantle beneath the Hawaii. So what he wanted to suggest is, suppose you are having a piece of plate here, and then you are having a hotspot which is pouring out the magma on the top. Okay, so you have volcanic eruptions here. Now once this move further, okay, then for example this has moved further, then you have this volcano will become dormant, and this place is again having the chamber, so you will have another active volcano over here. So that's how the whole chain was been formed. But another important feature which they observed was that they had like the volcanoes here like this, and then there was a sudden change in the direction. So this I will explain in the next slide, how they tried to map it and how they like concluded that the plate movement is there, of course, as well as the plate direction, or the direction of the motion changed over the time. Further, a hot buoyant plume of mantle rock continuously rise from the hotspot, partially melting to form magma at the bottom of the lithosphere, and magma that feeds Hawaii active volcanoes. So this is the source of the magma which feeds the active volcanoes. So if the seafloor moves over the mantle plume, an active volcano could remain over the magma source only for about 1,000,000 years. So further it will move, because the motion of the plate is not so fast, so it will remain for at least 1,000,000 years there, and then the next volcanic eruption will be experienced. So this is what you are having. This is the big island here, and these are all dormant volcanoes or the seamounts. So this has been shown as the present motion of the plate, which is moving above the magma chamber here. So if you look at the ages here, it shows that if you move away from this active big island, then you are having, like at present you are having 0.7 to 0 million years, and that is the present, and this is here 1.3, 1.8, 3.8, 5.6 to 4.9. So as you move away from in the northwest, okay, from the big island, then these islands are having the older ages. So, what they observed was the Pacific plate has moved northwest over the Hawaiian hotspot, which is located here, resulting in a chain of volcanic island and sea mounds. Third, the age of the mountains are consistent with the plate movement of about 100 millimeter per year. That is how they have come to the conclusion or the inferences which they have made is that one island will stay over the hotspot for 1,000,000 of years. So, at this point of portion, there is a sharp change in the direction which was around 43 million years back. So, there may be in some event which might have caused the change in the direction, but of course, this was not the direction which was observed in the present motion. Presently, it is moving in this direction, but the older ones are showing that they were having a different, almost north-south direction. So, I will stop here and we will continue in the next lecture. Thank you so much.